So what does that mean? What are plus or minus the square root of 2 at this point in time? They are critical values. Yep. So these are critical values. Now, how again do we find critical values? We set the derivative equal to 0, or what? Where it's undefined. Go back to the derivative. Are there any places where this guy right here is going to be undefined? What makes a function undefined?
The denominator is 0.
Wherever the denominator is 0. So are there any places here, x values, that would make the denominator 0?
When x equals 2 or negative 2.
Right. Does it make sense that this guy right here, if we had plus or minus 2, that would make a denominator of 0? So technically, we don't have just those two, but we also have plus or minus 2. There's 4 critical values in this problem. 4 critical values. All right, need some space here. I gotta take away this. This is where I need the big, right? Or the ruler. Or the smartboard. All right, so what next? What do I do?
Secondary? No.
Chart,
Oh, the chart.
right? So I've got x values, and then I have a prime. Now, I've got 4 of them here, but I'm actually going to use 2. Which 2? Common sense now. Just the positive ones. See? So who's bigger, square root of 2 or 2? 2. So square root of 2 here and 2 here. And what's my value of a prime here?
0.
And what's my value of a prime here? Okay. So that's what we have. So now we're going to fit values in between. So now here's the deal, just so we know what we're looking at. This chart that goes from 0 to 2 represents the x values that you would be picking here. Okay? So we notice that at the square root of 2, which is, I don't know, somewhere over here, okay, that's going to get your value. 2 is going to give you a value. What's the area of the rectangle at 2? 0. See that? This is your rectangle when x is equal to 2. Okay? Sort of have a problem there. All right? Rectangle does not have a height. All right, so what we're going to do is we're going to pick some values. Square root of 2 is about 1.4, so I'm going to pick 1 here. Square root of 2, we could pick a value like 1.5, but someone brought this up in the last class. I like that. We're going to use the square root of 3, which is about 1.7, because it's going to come in handy for our derivative. All right, so I'm going to recall our derivative, which was 2 square roots of 4 minus x squared minus 2x squared over the square root of 4 minus x squared. So what we have to do is we have to find a prime of 1 and a prime of the square root of 3. Just finding the corresponding values that go with that. All right, a prime of 1. I'm going to have to do this manually, see what we get. 2 times what? Square root of 3, right? Minus 2 over square root of 3. Is that a positive or a negative answer? Oh, positive. Okay? You should actually be able to common sense this. 2 times the square root of 3 is going to be bigger than 2 divided by the square root of 3. So therefore, for subtracting that off, we just need to know that it's positive. So this is positive here. Okay, let's do the square root of 3. 2 times, I'm going to do this here, 4 minus square root of 3 squared. See what I did? Minus 2 square root of 3 squared over the square root of 4 minus square root of 3 squared. Looks complicated, but it's actually not that bad. What does that give you? What do you get from this? 2. Because it becomes 2 times 1. It becomes the square root of 1. Okay, what do we get from this? 6 on the top, 1 on the bottom. So this is really 2 minus 6, which is a negative. So here's what we know. Plus 0 minus. Okay, what does this plus mean? Means that the area is increasing. Since A prime is positive, that means the area is increasing, and then here it's decreasing. So that means what occurs at 0? Maximum. So first we say this. I gotta clean this part off now. So now we say this. Therefore, a maximum occurs at x equals the square root of 2. Guess what? Because A prime changes from positive to negative. Okay? You must write your answer like that. Okay, that's justification that we have a maximum. Now let's answer the question. What was the question? Go back to the worksheet. What's the question? What is the largest area? Okay, so I think for this one I'm going to identify this. Let's identify length, width, and area based upon the information that we know. Okay, back to the original rectangle. What is the length of the rectangle? 2 squared to 2 is correct. Because x is the square root of 2, we just figured that out. And so the length is 2 square roots of 2. Okay, what is the width? How tall is this thing? Yeah, let's see here. Doesn't it come from the y-coordinate? And so the y-coordinate is the square root of 4 minus the x-coordinate, which we said was the square root of x. So, what's this? What's the square root of 4 minus the square root of 2 squared? Square root of 2. Okay. So, what's the area of the rectangle? 4 is correct. So it's 2 square roots of 2, that's the length, multiplied by the width, and we get an area of 4. All right, pull out your calculator. We're going to verify this on the calculator.